Okay everyone, here is a video about the Projectiles story worksheet. Feel free to skip ahead, watch it at 1.5 or double speed, whatever you need. So this is problem 1, and this is a horizontal projectile problem. We've got a speed of 14 meters per second and a height of 25 meters, and we're supposed to try to find the range. So what are we going to do here? We're going to set it up in a vertical direction and a horizontal direction. We're going to keep them separated. In the vertical direction, we're going to use our y equals 1/2 at squared, and then the horizontal direction we just have, oops, that should be an x. Yep, x equals v times t. And we're going to keep things separate. So this is something in the horizontal direction, that's our horizontal velocity. In the vertical direction, this is our vertical height, and the range is what we're trying to find here. That's the horizontal. So we're going to use the vertical direction first to find the time. So I'm going to just drop my units in these equations just to make them a little bit neater. 25 equals 1/2 times 10 for gravity. That's always our acceleration in the vertical direction, times time squared. Good. 25 equals 5t squared. And then we're going to get t equals the square root of 5. And if you want to throw that into a decimal, we can do that also. Let's see, square root of 5, 2.2. 2.2 seconds. Good. Now to find the range, this is going to be a problem in the horizontal direction. So I'll need my calculator, I guess. We are looking for the horizontal distance, and we're going to use this horizontal speed over here, 14. Once again, I'm going to drop my units just to keep things a little compact. 2.2 times 14, 30.8. And that's your answer. Okay, so now number 2 comes along, and it's asking us to find the total velocity before it hits the ground. So what does that mean? It means right here before it hits the ground, the velocity is going like this, or something like that. I don't know, I didn't draw my picture very well, because in my picture it's coming straight down, but it's probably, it's going off at an angle like this. So I'm looking for this total velocity right here. What I'm going to do is I'm going to label it as like VT for V total. And in order to figure things out like this using vectors, we can't really just deal with something that's going off at a funky angle. We need to split it up into components. So just before it hits the ground, it's got a horizontal velocity. This pen doesn't work very well, which I'm going to call Vx. And it's got a vertical velocity, which I'm going to call Vy. So it has a Vx and a Vy, and I can add those up in order to get the total. Sometimes it helps to draw these components as a triangle instead of drawing them like this. So another way I could draw it is, there's my V total like that, and I could draw it as a combination of Vy and Vx. And then if I add together Vy and Vx, then I get the total velocity, V total right there. And that's what I'm going for, the total velocity. And if you're a trig person, you could potentially figure out this angle if you wanted to, but that wasn't part of the problem. So how do I do this? Well, I need to find this Vx and I need to find this Vy. Vx is actually already given because in the problem, this 14 meters per second in the horizontal direction, it's always going to stay as 14 meters per second. So even when the ball is here, it's got a horizontal speed of 14 meters per second, and it's got some vertical speed too. And when it's here, it's got a horizontal speed of 14 meters per second, and it's also got some vertical speed. So the horizontal speed's always 14 meters per second. They're keeping things separate. Gravity doesn't act in the horizontal direction. So I know that this is going to be 14, right? Now we just have to figure out what Vy is. In order to figure out Vy, we kind of forget about everything else in the problem, and we say, hey, we're just going to drop something straight down to the ground, and how fast is it going just before it hits the ground? So if I'm looking for an equation that relates together velocity, or that can give me velocity, I can use this one, V equals AT plus V0. This will tell me the velocity at any given time, and I already know the time it takes for it to hit the ground because I already figured that part out, right? Initial velocity in the y direction, this is my vertical direction, is going to be 0. You might say, oh yeah, it has an initial velocity, but this is a horizontal velocity, so I'm not going to mix things up, I'm going to keep things separate. So to find the velocity just before it hits the ground, I'm just going to say my acceleration in the vertical direction is 10 for gravity, and my time was 2.2 seconds. That's going to give me 22 meters per second in the vertical direction. So that's this piece of the triangle right there, is 22. Now to find the total, I just have to do the Pythagorean theorem. So that is going to be, what do I have, 22 and 14. 22 squared plus 14 squared, and then I take the square root of that, and I get 26 for my total velocity, 26 meters per second. So that's my total velocity right there. All right, so this is a very classic physics problem where you have to do a bunch of steps in order to figure things out. Okay, let's move right along. I'm looking at my computer over here, and I'm looking at problem 3. So we're looking for, this time it's gonna be what I call a full projectile problem. So we're gonna set it up and gonna be kicking a soccer ball. So I generally like to set things up by drawing a diagram like this. I'm gonna call this V0, initial velocity right here. So in the problem it says we kick it at a 30-degree angle right there, and it says it has an initial velocity of 20 meters per second. And the problem here, problem 3, is to find what is this horizontal component and what is this vertical component. And once again, from vectors, we know that this 20 meters per second is equivalent to adding something that's going in the x direction. So I'm going to write this as like v0x. That means initial velocity in the x direction. And maybe I'll write this as v0y, initial velocity in the y direction. You can label them however you want to label them. There's lots of different ways to do it, but this helps me. v0x, v0y, and then v0 all together. And the problem is just asking what are the horizontal and vertical components of this. So how do we do this? Since this is a 30-degree angle right here, we can just go back to our 30, 60, 90 triangles. So if this is 30, and this is 60, and this is 90, the side across from the 30 is x, the hypotenuse is 2x, and the side across from this 60 degrees is x times the square root of 3. So I'm given this 20 right here, so that's my 2x. That means my x on this side has got to be 10, because this times 2 should give me that. And then this over here is going to be 10 times the square root of 3. And I like to label them with meters per second so I don't get confused and think of them as a distance or something like that, right? We want to make sure that these are labeled as velocities. Okay, moving on to problem 4. Problem 4 says what's going to be the maximum height that the ball is going to reach right here. And so it says it's a two-step problem, and what we're going to do here is we're just going to imagine that nothing else exists except for this initial vertical velocity. So it's like we kind of want to rewrite the problem and do a whole separate problem. So let's do that. Let's just rewrite this over here. And what we've got is, in the vertical direction, we're starting out with something that has an initial velocity of 10 meters per second, and we're trying to figure out how high does it go, right? What's the height right there? And the hint is that we can use this equation, v equals at plus v0, to find the time it's going to take to get to the top here, and then use our good old y equals 1/2 at squared equation to figure out how high it goes, right? And then there's a really quick and easy way to do it, which maybe I'll just put over here, which is just saying if I want to find out how far something goes, which could be x, but since we're in the y direction, I'm going to write it as y equals average velocity times time. So I think this is a nice and quick way to do it, but in the instructions I said to use these. So what are we going to do here? First, let's use this to find the time, and then we'll put the time in over here. Now I know just using some logic, we can actually figure out how much time it's going to take for the ball to get to the top of its path. We start out at 10 meters per second. Gravity is going to take away 10 every second that we're going. So we start out at 10, and 1 second later, we're going to have a speed of 0 meters per second. So it's going to take 1 second for it to reach the top of its trajectory. Some of you are like really equations kind of people, and you're like, hey, I need an equation in order to figure this out. So let's use this equation right here. We're looking for the time. We have the initial velocity. The final velocity at the top here is going to be 0, and we know that our acceleration for gravity is 10. We just have to pay a little bit of attention here in terms of our directions. So usually we're going to pick positive in the up direction and negative in the down direction, right? So what does that mean? It means in this equation we're going to say 0 equals gravity. This time I'm going to put in -10 for gravity, plus, times time, plus my initial velocity of 10 meters per second. And then I think you can see that the algebra here is going to tell us that t equals 1 second. So 1 second to get to the top of its path. Now we can figure out the distance from either of these equations. So let's use this one, y equals 1/2, and gravity's 10, and then 1 second squared. So that's going to give us 5 meters. That's how high the ball is going to go. The maximum height is 5 meters. You could also use this one, average velocity times time. The average velocity between 10 and 0 is 5. 10 plus 0 divided by 2. So this is going to give me 5 meters per second times 1 second, which also gives me 5 meters. And that's great. So it all works out. So that was problem 3. That was problem 4. Yep, that's problem 4, which was finding the maximum height. Problem 4. Good, okay. Moving on, we're still gonna need this setup here. So this is problem 5, and it says we're gonna figure out how long does the ball stay in the air before it returns to your hand. So this is the same information from this problem that we used before. We're gonna find the total time in the air. Okay, well, how hard is that? Well, it's not really so challenging because we already have the information over here. I'm gonna grab a different color. Okay, so what are we doing? If I'm finding the total time in the air, it's just gonna be twice the time that it already took me to get to the top, right? So we have t equals 1 second, which means the total time is gonna be 2 seconds. Okay, so that's pretty easy. Some of you might be thinking, hey, I wish that there was an equation that can help me figure this out. And there is an equation. It's the same equation right here. And, oh, that went a little off the paper, I think. Oh no, we still got it. Move that out of the way, okay. It's still the same equation right here. And v equals at plus v0, but let's solve that for the time in the air. How are we gonna do that? Well, we start out with an initial speed right here, v0. Ball's gonna go up, it's gonna come down, and it's gonna have a final speed v right here. I think we can probably reason from logic that v and v0 are gonna be the same, just in opposite directions. So I can make a little statement that says v equals minus v0. It's just the same value in the opposite direction. Now I can come back to this equation, v equals at plus v0, and do a little bit of algebra here. So how can I do that? I'm gonna substitute in for this right here, this negative v0 right here. So I'm gonna say negative v0 equals at plus v0. Bring this other v0 to the other side. So I'll get negative 2 v0 equals at. I'll bring the negative to the other side. 2 v0 equals negative a times t. Okay, and now we can just, remember we're looking for the time. Now we can just plug in numbers to this if we want to. 10 meters per second, and then just considering this 10 meters per second was in the up direction, so this a, the gravity, has to be in the negative direction, the down direction. So here's how this is gonna work. 2 times 10, that was our initial velocity, equals negative, and then this is negative 10 for gravity times the time. Cool? Divide all this out, and you're gonna get t equals 2. Good? Okay, so that's the answer to that one. That's problem 5. Now problem 6 is finding the whole range of this thing over here. So let's go back to this one. It's the same setup. And what I'll say is we've already figured out that the time, the total time, is gonna be 2 seconds. And so the total time in the air is 2 seconds. And then problem 6 is saying, oh, actually, sorry, it's a different setup. But let's just follow through on this one in case we wanted to find the range on this one, and then we'll actually do problem 6. So if we wanted to find the range here, that's the x direction. So that's gonna be, I'm gonna put down here, the x velocity times the time. Here's our x velocity. The initial velocity in the x direction is always gonna stay the same. It's always gonna be 10√3 meters per second in that direction. So if I'm gonna find the range here, I'm gonna say x equals this speed right here, 10√3 times the time of 2 seconds. So that's gonna be 20√3 meters. Now that wasn't one of the problems, so that was just a little bonus that I was doing for you all. Okay, let's move over here and let's talk about actually problem number 6 now. So here's problem number 6. It's a full projectile range. So we're going to start with our usual thing here. We're going to start with a v0, and we're going to start with an angle. This time the initial velocity I said was 21.2 meters per second, and then this angle is a 45-degree angle going up like that. Okay, there's a reason I picked 21.2, and you're going to see. So how do we do this? Well, same thing as we've been doing before. We're going to split this up into a horizontal piece and a vertical piece. So this is going to be my initial velocity in the x direction. This is going to be my initial velocity in the y direction. And we got to figure out what these two things are. So we have to like undo the Pythagorean theorem here. And just reminding ourselves about 45, 45, 90 triangles. If this is 45 and this is 90, if this side is x and this side is x, and this side is x times the square root of 2. So in order to get from the hypotenuse to one of the sides, we have to divide by the square root of 2. So if I take this divided by the square root of 2 should give me that. Right? This divided by the square root of 2 should give me that. So let's try it out. Turn this on. So I'm going to clear that. I've got my 21.2, and I'm going to divide it by the square root of 2, and I get 14.99. Okay, so really that's 15, and that's why I picked that 21.2, because it was 15 times the square root of 2. So 14.99, that means that this is 15 meters per second, and then this one's also 15 meters per second. I want to make sure, once again, we're recognizing that these are velocities. These are not distances. And what I want to caution you is, I hesitate to tell you things not to do because I don't want you to get it stuck in your head, but what I often see students do in this kind of problem is they'll set this up and they'll draw this like this, and then they'll figure out this and they'll figure out this, and they say, oh, if this thing is going to fall over here, I'm just going to make another triangle over here like that. And I'm going to say that this is 15 and this is 15, so this whole thing right here is 30, okay? Not what we're doing here, because these right here, these 15s, this is a velocity. This is not telling you how far the ball is going. This is telling you what is the velocity of the ball at this point right here. So you can't just draw two triangles side by side and then add them up, right? But we can figure this out. So ultimately, we're trying to find the range. So we're looking for the horizontal direction. We're just looking to do x equals vx times t. And the vx is just this right here, right? Once again, this velocity is going to stay the same the whole time. So that's that right there. We need to find the time. In order to find the time, we're going to use the vertical direction to find the time. So how do we do that? Well, we have this initial vertical speed of 15 meters per second. So let's redraw a problem here. And we're going to say you're launching something straight up with an initial speed of 15 meters per second, and we want to figure out how much time it takes to go up and all the way down to find the total time. Okay? So we could use equations for this if we want to, or we could just kind of logically figure it out. If we wanted to use equations, we could go back over to what we were doing before, right? And this is what we figured out before this little line right here. Okay, so we did this before. Let's copy that over here. So we said that 2v0 was minus a times t. In fact, what I would like to do is one more algebra step here in order to say time equals. That would be a nice thing to do. So if I just rotate things around, I can say time equals 2 times the initial velocity divided by negative acceleration. And remember, the negative sign is there just because we needed to keep track of things that were going up and down. So if I put in gravity over here, one more step down, t equals 2 times v0 over negative 10. Remember, gravity was going down, and we chose down as negative here. So we're just keeping track of our negatives. And so the time is really 2 over 10 times the initial velocity, or I could say that it's the initial velocity divided by 5. Okay, so that's how we can actually find, and this 5 it comes because it's half of 10 over here. Yep. So we'd actually find the time in the air by just taking this initial velocity and dividing it by 5. So if we start out with 15 meters per second, divide that by 5, that's going to be 3 seconds in the air, right? So that's how we can do it. That's just sort of a quick way to figure things out. So now we're going back to figuring out what the range is. Now we have the time in the air is 3 seconds. Now this is pretty easy. To figure out how far it goes, I'm just going to say 15 meters per second times 3 seconds. That's going to be 45 meters. And that's going to be our range. That's how far this ball is going to go. Okay, and then lastly we have problem number 7, which I'll do down here. It's just another horizontal velocity problem with finding the range. So I'm going to set it up just like we do the other ones. Make sure you all can see this. Good. We're going to have an initial velocity right here, and that's given in the problem as 50 meters per second, and we're trying to find the range, right? Same process. Oh, sorry, and then the angle over here is a 53-degree angle. 53 degrees. So we're going to set this up the same way. I'm looking for an initial velocity in the x direction. I'm looking for an initial velocity in the y direction. This time we have a 3, 4, 5 triangle to deal with. So how do those work? 3, 4, 5 triangles. The 53 degrees goes with 37 degrees, and that's a right angle right there. So the side across from the 37 is going to be 3x, and this is going to be 4x, and this is going to be 5x. So 3, 4, 5 triangle. It could be 6, 8, 10, or it could be 9, 12, 15, something like that. So we're going to just work backwards over here, and I know that if this side is 50, that's 5 times 10. So this side's got to be 4 times 10, and this guy's side's got to be 3 times 10. So this side is going to be 40 meters per second. This side is going to be 30 meters per second. I'm going to keep things separated again. We've got something going in the horizontal direction, and we've got something going in the vertical direction. In the vertical direction, we're going to find the time. The time in the air, our quick way of doing it is taking that and dividing it by 5. 8 seconds. Cool? Now there's a reason for that, so don't think it's some mystery. Why am I dividing by 5? That's weird. Well, we figured out that through this whole process of using the equation, if you take that and divide it by 5, you can get the time in the air. Consequently, if you take this and multiply it by 5, you can get the initial vertical speed. Cool? In the horizontal direction, we're just doing x equals v times t. Where you're going to use our horizontal speed right there. Very important, right? Use the horizontal speed. So this is 30 times my time in the air is 8. That's going to be 240 meters. So that's the answer to that one. And that is number 7. So that's it for George the Turtle and his urban adventure. Hopefully this was helpful for you.